Are we alone here in the universe? Or is there extraterrestrial life? This search for signs of life in our universe is the motivation for NASA's Europa Clipper mission. Clipper is set to launch in October of 2024 and will reach its destination in April of 2030. But what is Europa? Europa is an icy world, almost 400 million miles away from Earth. It is one of the 4 Galilean moons of Jupiter. The Galilean moons are a remarkable area of our solar system, consisting of the most volcanic world and the largest moon in our solar system. So, why are we choosing Europa? Well, this has to do with the phenomenon of tidal heating. Jupiter is so incredibly massive that it interferes with the orbit of Europa. In fact, the pull of Jupiter's mass causes the entire planet to stretch and contract like a stress ball. This pull is a much more extreme version of the one that causes our ocean tides here on Earth. So, this heat from the tidal flexing is what allows Europa to have a complex environment, including a liquid ocean. Preliminary studies show us that surface disturbances called lenticulae and chaos terrain, like these cracks and ridges, might be caused by convection currents within the ice and ocean. In other words, Europa's ocean could have hydrothermal vents like we see on Earth at the bottom of our ocean. Some of these features also are believed to be composed of salts like sodium sulfate. Bringing all this together, we have a stable liquid water source, a source of heat or energy, and elements needed for life to exist. All the requirements for life could be here on Europa. And this brings us to Clipper's mission goal: to determine whether there are places below the surface of Jupiter's icy moon Europa that could support life. And while Clipper will not land on Europa's surface, it will make nearly 50 low-altitude flybys. Through a gravity assist from Mars and Earth, Clipper will enter into Jupiter's orbit and begin its first flyby in the spring of 2031. It will reach altitudes as low as 16 miles above Europa's surface and scan close to the entire moon's area. And as you may have guessed, Clipper is still being assembled at NASA's Jet Propulsion Laboratory, with assistance from other labs. When complete, Clipper's solar panels will be large enough to span about 1 1/3 semi-trucks. So it takes some time in order to assemble all of Clipper's scientific equipment, or payload, which is what will allow us to achieve this scientific goal in the search for extraterrestrial life.
The payload can be more or less divided into 2 main categories. That is, equipment that will collect information about Europa's surface, and equipment that will collect information relating to subsurface processes, like things happening in the ocean. Starting off with the surface processes, one of the main goals of this mission is to categorize what exactly is happening at the surface. This begins with taking pictures using the Europa imaging system, a wide and narrow angle camera, and also by mapping the surface composition. Data on surface composition will be collected using the Mapping Imaging Spectrometer for Europa and the Mass Spectrometer for Planetary Exploration, which will tell us about the salts, organics, and minerals found on the surface, and in turn tell us more about the composition of the subsurface ocean. As we said before, there's also been evidence of potential vents erupting plumes of water into space, so Europa Clipper will also be collecting data on the composition of ejected material using the Europa ultraviolet spectrograph and the surface dust analyzer, and will also be collecting information about where these vents might be using the Europa thermal emission imaging system. This data can tell us more about geologic processes going on in Europa, so we can make connections between what we see on the surface and what's going on beneath that. Clipper will also be collecting a lot of data about Europa's subsurface, mostly using radar. This satellite will measure the thickness of Europa's ice sheet with an ice-penetrating radar, which is abbreviated REASON because it has a really long name. Clipper will also measure Europa's magnetic field using a plasma instrument for magnetic sounding and a magnetometer. These 2 instruments will work together to figure out where there are anomalies in Europa's magnetic field, which can tell us information about the properties of the subsurface ocean. Clipper will also have a gravity and radio science instrument, which will tell us about its gravitational field. Information on Europa's gravitational field will help scientists figure out how deep the ocean floor is, so we can constrain information about its habitability. All of these instruments will collect data that fits within the mission's three main hopes and goals: to understand the properties of Europa's ocean, to understand Europa's geologic processes, and to understand how these two things interact with the ice surface. If we have information on these things, we can put together a picture of what Europa might look like in terms of habitability and draw parallels to environments on Earth.
So, zooming out back to the big picture, Clipper is a key step in our search for signs of life in the universe. And most likely, its results won't show sci fi aliens, but who knows what lies beyond.